Hi everyone, I hope all of you can hear me and see me. Please do let me know before I start this session. And hi Shivani, hey Shruti, hi Nandini, hi Vishnu Kumar. So I hope that all of you can see me and hear me, and you can also see the slides. Is it? Please do let me know, okay, so that I can start the session. Thank you, Shahrukh. So we all know that in this session we are going to cover Maths Beyond Books. This is for senior grades. Basically, we are covering the book of grade 8 and grade 9, to be honest. And most of the questions are from grade 9 math book. Okay. But yeah, a grade 8 math book has those kind of concepts. So we just scaled up the difficulty level of the problems for them. Okay. Okay, about practically, I hope you are already aware of now. So you get a personalized mentor if you subscribe for the courses, and then you get doubts cleared through text or video. You get to be taught by India's best teachers. Moreover, you can learn coding here, and there are so many simulations here which you can go through, and you can learn some basic to advanced level concepts in easier way. Okay, that's cool. And we are running this workshop already. You know that YouTube Pro and Scratch programming, chess, math beyond books. There are two types. Science beyond books, two types. Then gaming with Unity and robotics. So robotics intro was started yesterday itself, and the regular classes will obviously work on the same schedule that you already have in the app. Okay. Then there are some rewards associated with each kind of thing. If your attendance is good, you are coming daily on this course, you are attending 70% say, but you give the best project and we select the best projects out of it. Then you can refer your friend and you have the best question also. Hi everyone. This is the session 5 of Math Beyond Books, and today is kind of a homework doubt session combination. So I'll be solving that one question last, the homework question, and then we are going to solve the some doubts from you if you have. Otherwise, I'll solve some mixed problems of exponents and coordinators, because these are the chapters we have covered. Number system is very simple, so nothing much to be asked, unless yeah, of course you have some doubts. So I'll begin in like a 1 minute also, because there are few people who are still joining. What's my native place? That's not relatable to math, by the way. Maybe I'll make another video on it. That would be better, isn't it? Yeah. So Namaste is happening. I'm fine. Shruti has asked me just now this. Okay, so you all must have started practicing a little bit questions from some books, whichever book you are following, R.D. Sharma, R.S. Agrawal, NCERT, correct. And now you must have seen some different kinds of questions also. So this is what we are in. So we are into this homework and doubt discussion, and this is the 5th session for today, 5th May, 5th session. That's good. That's cool. And is May also 5? January, February, March, April, May. Yeah. So this is 5th of date. This is 5th of May. So this is 5th month, and we are doing the 5th session. Super. Quite a coincidence, by the way. Okay, this is where you have some questions you can ask. This will be the mixture of these problems based on these chapters, so that if you have some issues, you can easily and comfortably ask today. Got it? Let's move to the next first question, which was the last homework question. Today handwriting is good. Everything is good. Finally, that's so good. I can't tell you that. So the first question, which was actually the last question homework, the last session homework, I'm sorry. So which class is this? Hey, it's a mixture for 8th and 9th. So if you are still in 9th, still like you have gone in 9th, this will be the super helpful class. But maybe suppose if you have passed 9th and you are in 10th, then you will be able to see some of the things which you may have missed. And these concepts will obviously help in class 10 geometry. So it's like for both grades. For honestly speaking, I'll say 60 to 70% it is for those who are in 9th, 30% it is for those who are going into 10th and they have some misconceptions still. They can clear. Got it? Fine. Let's begin with the last session homework. So this was the last session homework. Okay. You all know that in general, if ABCD is a rectangle and in which diagonal AC bisects angle A as well as angle C. So it is given that it's a rectangle, okay, and the diagonal is bisecting both the angle A and the C. So this angle is being bisected and this angle is, so these two are equal. then angle C is also equal. This is also bisected. Now what they are asking you to prove, that first you prove ABCD is a square. Okay, you know that any rectangle will become a square if the sides become equal. So all the sides become equal. Correct. Now you must be aware of this very important point, that even the diagonals will bisect at 90 degree. So in rectangle, the diagonals do not bisect at 90 degree. So if this is say alpha and this is beta, then alpha and beta are not equal basically. That's in the case of a rectangle. Okay. But in a square, they are equal, and they are both equal to 90 degree each in case of square. Okay. Now the trouble is, which way will you select to prove this? There are two ways of doing this. Either you can prove that all the sides are equal, or you can prove that the diagonals are bisecting each other. They are, of course, but they are bisecting at 90 degree. Okay, someone is telling me ASA. Lava, diagonals are also equal. That is in the case of rectangle also. The diagonals are equal in the case of rectangle also. Yes, Lava, that's true. So if we are considering that, we can consider this also. By the way, let's do some basic maths before doing this. What's the basic math here is, it's very simple that if the angle is being bisected, we know that in a rectangle, all the angles are 90 degree each. So each angle is 90 degree. Now if I bisect a 90 degree angle, of course this is very simple to find. It will be 45 degree each, isn't it? Now if this angle will be 45 degrees, then what's the trouble? Why to write x and y? We can just write this as 45 and 45. So let me bring the eraser. Give me a minute. Okay, so let us say that this is actually 45 only. So this is 45, this is 45, this is 45. Remember one very important point, that the diagonals bisect each other and they are equal. So we can say that AC is equal to BD. So if I say this is the intersection point, then this implies half of AC will be equal to half of BD. Correct? So what is half of AC? I can say it is OC, or I can say it is OA. Correct? So OA, just a minute. So OA or OC, let us say OC, and half of BD, let us say OB. Okay, so this gives a very simple scenario, that if it happens, if the diagonal is bisecting this will only, if this is in general, diagonals do not bisect the angle, by the way, in rectangle. I hope you are all aware of this point, that in a rectangle the diagonals do not bisect the angle. It means the diagonals are not the angle bisectors. But since it is given to us, I am using that fact. And now what it gives us, that OC is equal to OB. Now this gives me a very good situation. Now you see how I am doing it. I don't need congruency. This is what I am teaching you. I don't need congruency actually. So what I end up doing is, I find that this side is equal to this side, because half of them is equal. This gives me that the opposite angle should be equal. So if this is 45 opposite to this angle, the side is equal, so side opposite is 45 degree. So again this opposite angle should be the same, so this will be 45 degrees. Pretty cool, isn't it? Now if this is 45 degrees, this is 45 degrees, this should be 90 degrees. So I just now proved that beta should be 90 degrees. Correct? Because the sum is 180. You got it? So now you see this is 90, so alpha is 90. So now you can say, if you wish, that since the diagonals are equal, this is a property of a square also, since the diagonals are equal, bisecting each other at 90 degree, hence this will be a square, because in rhombus the diagonals are not equal. That's the point. So it cannot be a rhombus. So I can just at this point say, and it will be true. But let's say that I am not saying it. Let's say I am not saying it. So I can still go and prove, this is what you people were telling me last time, I can still go and prove that triangle OBC and triangle ODC congruent. Do you all get it? Now, OBC and ODC are congruent, and it's very easy to say. The reason is, see, these two are equal. Since OB and OD are equal, diagonals are bisected. So OB is equal to OD. Also, you notice that OC is common. So OC is common. Now, what is that angle? This angle, the packing angle. All of you focus on the packing angle. I just now proved that the packing angle is 90 degree. I proved that beta is 90 and alpha is also 90. Since it is a straight line, so the sum of the angles should be 180, linear pair. So now I proved that this angle, which is forming at here, is 90. This angle is also 90. So the common angle between the two sides for any triangle, that is angle BOC, is equal to angle DOC, and it is equal to 90 degrees. And hence by SAS we can say that triangle OBC is congruent to triangle ODC. And if it is true, which is because of SAS, we can say that the side BC is equal to the side CD by CPCTC or CPCT. But you know that in a rectangle, if adjacent side become equal, actually all the sides will become equal. So we can say that this implies AB is equal to CD, but AB and BC become equal, but BC and CD become equal. But if BC is equal to AD, so it is equal to AD, all sides become equal, and hence this is a square. Do you all get it? Do you all get it? I told you two different ways. Shilpa, I just told you. Remember, I told you that if they are bisecting at 90, this is enough. This is the property of a square. But let's say we don't want this to happen. We can still go and prove the two triangles congruent, and we can prove all the sides equal, which I also said in the beginning that I can still do this problem if I take into account that if the sides become equal, then this rectangle becomes a square. I hope this is fine now. So there is no rush because this is our doubt and discussion session. So I'm like super chill today, like super chill. So even if you have a lot of questions to ask, you can ask me today. Like it's like totally open. This is an open class, okay? This is not a closed class. A closed class is one in which I am like controlling things. So it's an open class. You can control a lot of things. You can't ask me silly questions either. Silly means where are you from? Do you like this? Do you like that? I'm not telling you where I am from and what I like and what I don't like. That's my personal life. Okay, so let's move to the next one. Okay, you all people have understood this. Okay, the second part is done. When I say diagonal BD bisects angle B, then obviously if this is 45, I just now proved that this is 45. This gives me the fact that this should be 45. Why? Because the total angle is 90 degrees. One of the angle I found was 45. So say that since angle this was found to be 45, because the sides were equal and hence the angle became equal like that way. So this you can say it is 45. Then since this is a parallelogram also, the alternate interior angles will be equal. So this is 45, this is 45, this is 45, this is 45. So we can easily say that BD is also bisecting angle B as well as angle D, since the two parts of the angles are equal. You got it? You got it. Then let's move to the next one. There are so many things written. They have been done in a different way. So many ways of doing it. It's your choice again. Let's move to the next one. Okay, so this starts. I am Hindi or Telugu. Okay, not answering that. In a parallelogram, the diagonals are equal. True or false? So now I will ask you like 4 or 5 true or false, just to like combine whatever I have taught you so far. So we can go and combine the problems now. So there will be a mixture of problems. True, Nandi came up with true. False. Okay. Okay, that's fine. That's fine. In a parallelogram, the diagonals are equal. True. Tejas says true. No, beta, it's false. You people are missing the answer, huh? In a parallelogram, the diagonals are never equal. If they become equal, it will start to become a rhombus, actually. See, in a parallelogram, what happens? Let's say I've been given a parallelogram, okay? Think about it, okay? Let me prove it for you before I directly say no. So now I have been given a parallelogram, say ABCD. Okay. If I am saying the diagonals are equal, then these two parts, diagonal bisect each other. So basically all the four parts will become equal. Correct? It will become equal. Now if it happens, then you have to understand that since all the four parts are becoming equal, I can prove that this triangle and this triangle become congruent, or I can prove that the adjacent triangles start to become congruent. So all the sides will become equal. So indirectly you will lead to rhombus. You get it point? Because these two will start to become equal somehow. Correct? Which is not the case. So you can prove that these two triangles are congruent, which is true of course. But then you can also prove that adjacent triangles are congruent. So this will become a rhombus. And it's written parallelogram only. It's not written rhombus. So you cannot say a parent property to a child property. Okay? A rhombus is a child of a parallelogram. It's a special case of a parallelogram. Okay. You okay, Shahrukh? Yes. Or did I set rhombus? Should I set rhombus? Let me just go through it. Wait. So it will then become a rectangle, I guess so. Yeah, it will become a rectangle. Thanks for correcting me. Yeah, because the angles will start to become equal. And this angle is equal to this angle, and this angle will become equal to this angle, and hence this complete angle will become equal. Yes. And then it will turn to a square. Correct. See, I'm missing it. Yeah, square 2. Okay, let me just prove it then. It's better I prove it right away. Let us consider, since nothing else is, no other point is given to me, so I'm assuming that, okay, wait. Okay, let's say I have been given a parallelogram. Okay, I'm going to prove it, what it will become for all intent and purposes. Okay. In a parallelogram, the diagonals are equal. Let's say the diagonals are equal. Let's say they are. Then, in general, they are not. Okay, the answer is false and I can move ahead because that's the property of a parallelogram. But let's say if the diagonals become equal. So in that situation, this part, this part, this part, this part will all become equal. Yes. So this triangle will become congruent to this triangle. Yes. Why? Because these are vertically opposite angles. So the triangle, I'm writing the name, AOD will become congruent to the triangle AOD. This is the triangle, and COB. Correct? This is true. So I'm repeating it, beta. So the triangle AOD is becoming congruent to triangle COB. Sorted. This is sure. Okay. Now you know that if this angle is X, this angle is X. If this angle is, say, Y, this angle is Y. Correct? Now let us focus that can we do something else here. Now since the two triangles, these two triangles, can you prove that these two triangles also become congruent? I think we can't for now, because this angle is not X unless this is the angle bisector. You get the point? And it is not given. So this is half information. So we just have to rely on this fact that's why everything was becoming true. Like rhombus was becoming true, square was becoming true, rectangle was becoming true, because everyone was taking something or another in his mind. Okay. So what we do that, we say that angle bisector is not given. So we cannot say this is X and this is X. If this becomes X, listen to me very carefully. Okay. I'm just proving the point. If this becomes X, then this will become X. And hence these two triangles will become congruent. And then the 90-degree will pop up and it will turn into a square. The last question. Correct? But which is not happening as of now. Since this is not given, what is this angle bisector or not? And therefore, we just have to stop and say no based on the properties. Do you all get it now? And this is not true so far. Okay? I hope you have understood this far. No one has said anything. Is my chart stopped? What has happened? Okay, Shahrukh, you got it. Fine, Deepika. Let's move to the next one. In a parallelogram, does the diagonal bisect each other? At any degree, Shivani. Diagonals intersect at each other at any degrees. It's not sure. It's totally random. The diagonals do bisect each other. That's a true point. So that's true. The diagonals bisect each other. Okay. False. No, the diagonals bisect each other. The diagonals are not equal, but I remember I told you something that they are like a knife and the other one is a cake. So the diagonals do bisect each other, but the whole issue is that these two are equal and these two are equal. You get the point? Not every diagonal is equal. You get the point? So these two are equal and these two are equal. So diagonals do bisect each other. Okay. Okay, the next one. In any quadrilateral, if a pair of opposite sides is equal, it is a parallelogram. So in any quadrilateral, if a pair of opposite sides is equal, if a pair, only one pair is equal, it is a parallelogram. False. It is false. I hope you all remember trapezium. Yes, Shahrukh, correct. In a trapezium, I told you, in an isosceles trapezium, I told you that a pair of sides can become equal, opposite side, but these two, if they are parallel, they are trapezium. You get the point. So this is false because it can be trapezium too. Yes, Shruti, absolutely correct. This is what it is. It can be trapezium too, and hence it is a false statement. It is not a parallelogram. Both the pairs should be equal. That was the correct theorem. See, you people are still missing it. Okay, let's do the next one. Yes, Samiha, you are correct. Okay, if all the angles of a quadrilateral are equal, it is a parallelogram. All the angles are equal. It is a parallelogram. Tejish, that's what I taught you, no? That can become a trapezium. I showed you just now. Like the two lines are parallel, the two sides, these sides are equal. Not necessary that these are also equal. Not necessary. Okay. If all the angles are equal, it is a parallelogram. Hey, if all the angles of a quadrilateral become equal, so all the angles are equal, it is a parallelogram. No, it's not a, so it's a special parallelogram, but it is not a parallelogram. You cannot call it a parallelogram. You call it either a rectangle or a square beta. Samiha, it can be a rectangle also, it can be a square also, no? But not a parallelogram. A parallelogram, so that's what I'm saying. You cannot put the child name. You cannot put the parent name always. Then parent will always be true. No. There will be no question to be framed. So you have to select the perfect name. The perfect name will either be a rectangle or a square if all the angles are equal, because then the sum of the angles, you know that the property of any quadrilateral, the sum of all the angles is equal to 360 degree. This implies that 4x will be equal to 360 degree, but this will give us that x is equal to 90 degrees. And hence all angle is 90 degree. So either a square or a rectangle. Correct, Purna? You all people now understand. So it is a parallelogram? No. It is actually rectangle or square. Parallelogram, just parallelogram. You cannot say for everything parallelogram. Then everything is a parallelogram. You get it? Okay. If three sides are equal, it is the parallelogram. Shruti is not required, that square should be there. That's what the point is. Because rectangle, angles were taught, not the sides, no? That's why. Okay, so three sides are equal, no, false. It's not like that. Any three sides if are equal, it's not necessary the fourth one is also equal. You get the point. So I can just create one side like this way. This may be equal to this side, and I just join like this. It's not a parallelogram. You get it? So it's not necessary it is a parallelogram. Okay. Okay, next. If three angles are equal, it is a parallelogram. What do you say? If three angles are equal, it is a parallelogram. No, it's not. Three angles, we are looking for opposite angles to be equal. In a parallelogram, remember one very basic property of it. In a parallelogram, the opposite angles are equal. Just that is true. Rest everything is not leading to it a parallelogram. So it's correct. It's a false statement. Okay, next one. If all the sides are equal, it is a parallelogram. it can be a rhombus or a square. Again, if you go like this way, everything is a parallelogram. You get it? But yes, you can say true if you want to. But then you have to think in the terms of parallelogram. You get it? So this is a very ambiguous question to be answered. If you yes, this is what I'm saying, Nandini. If you go like this, that okay, all the four sides are equal, yes, that it is a square, and a square is a parallelogram. So yeah, it is a true statement. Okay, this is an ambiguous statement, to be honest, because if you think it should be called a square, why you are calling it a parallelogram? But if you say no, all squares are parallelogram, so it is a parallelogram, then you are true. That's the whole trouble. So that's where the trouble is. This question should be answered. It is a parallelogram, and if I write like this, and not a square, then it is a false statement. It may be a square or a rectangle, true statement. You get it? Then only, otherwise not. Okay, done. Those are like some little bit tricky questions, but we have to come and think like which way we are going for. If you look like that, if it is a square, it is a parallelogram, obviously it is a true statement then. Okay, so I will leave the answer as true. Okay, let's come back. Can you all do this? Simplify and tell me what I should write. X to the power what? I want this term. What should I write? I hope you remember the laws of exponent. So these questions are based on the laws of exponent beta. Vishnu Kumar has come up with that x to the power 1 by 6. Okay. Someone else? Everyone is coming with that. Let me see. So first I will write x raised to the power 2 by 3. Why 2 by 3? Because this is 1 by 3 coming out. And this is raised. This is 4. So basically fourth root is just 1 by 4. Correct. So this will be x raised to the power 2 by 3 multiplied by 1 by 4. So if we simplify this, we get x raised to the power 1 by 6. Absolutely correct. Question not clarity? I don't get it. The question is written like this. It's not clear. So it's like the third root. So it is 1 by 3. Pushpa, don't go with the decimal. Okay. Next one. Let's simplify this one. So this is written like root over xy square cube root of it divided by x square y. What do you all say? Let me wait for it. Okay, so what do you say? Someone writing something, or shall I write something? Shall I simplify this? Okay, so let's solve. So this will be xy square. Okay, so if I write this, this will be xy square whole to the power 1 by 3, because this is the third root. Now you know division can be changed into multiplication, then you have to write this into fraction, the reciprocal of it. So you write the reciprocal of it. Okay, now you can see the powers are written like xy square. So you remember this law that ab raised to the power m is nothing but a to the power m times b to the power m. Correct? So now you can write this as x to the power 1 by 3 and y square to the power 1 by 3. And this is in the denominator as x square y. Now, you all know that x to the power 1 by 3, fine, y2 into 1 by 3 will happen, because this is y to the power. So powers get multiplied. So 2 by 3 it will become. And this will be divided by x square y. Okay, so now I can bring all these powers in the denominator. So there are two ways of doing it. Either you can bring in the numerator the power or the denominator. So you know that there is one what I call a law, that if it is written as a to the power m upon b to the power n, I'm sorry, not b, a to the power n, then you can write it as a to the power m minus n. Also, you can write this as 1 upon a to the power n minus m. Both are true formulae. Don't think that one is true. Both of them are true. Beta 2 by 3 in y, Shruti, because you see this is y square written, no? So y square is having a 2 power. So this power into power to power, powers get multiplied. Remember this law, a to the power m raised to the power n. It is a to the power mn. I hope you get it now, Shruti. So this is the reason why you have to write like this. X square y, it is written like x square. So sorry. So y square. So 2 into 1 by 3. So 2 by 3. You got it? Now I hope so. So now I can actually send this one to the denominator. The reason I'm doing it is pretty simple, because these powers are actually less than 2 and less than 1. Okay. So now I can go and I can just change, and I can write this as x1 upon, now closely watch what I'm writing. I'm writing this as x to the power 2 minus 1 by 3. Why? Because a to the power m by a to the power n is 1 upon a to the power n minus m. I can bring anyone below or anyone up. I have to just change the sign of it. Just change the sign of it. I'm not saying minus. I'm saying change the sign of it. So if it is minus above, it will become positive below. If it is negative below, it will become positive above. Change the sign. Now, Shilpa, you gave me the answer. I didn't see it, beta. Can you please resend it? So now you get y to the power. So this is nothing. It means 1, not 0. So 1 minus 2 by 3. Now this will give us 1 upon x raised to the power 2 minus 1 by 3. So 6 minus 1. So it is 5 by 3. And y to the power 3 minus 2. So 1 by 3. So this is the answer. You can still pack it like 1 upon x to the power 5 times y whole to the power 1 by 3, because both of them have 1 by 3 in common, and that can be put, because 1 to the power 1 by 3 is for all intended purposes, for you 1 to the power 1 by 3 is 1. Actually it is not just 1, it is omega and omega square also, because it is the cube root of unity, but we are not reading that, so let's leave it. Charan, you are giving that one is also fine. I am correct. You are correct. Everyone who has given the same answer as this one is correct. Did you all get this one? Can I move to the next one? I'm telling you the difficulty level is going to rise like this. Crazy. Okay. The next question will be a little bit different and difficult. So if you're not getting this, you're going to get a lot of trouble. If you have some questions to ask to me, you can also ask, by the way. If none, I'm moving ahead. No one is telling me anything. I just told you. Something will happen. Now you people have to simplify. I'll give you enough time to solve this. I want all of you, I want most of you, actually all of you, to give me the correct answer. So now let me see if you can give me the correct answer. It's going to be a little bit tough. You have to like apply everything that you have understood, all different laws, like every law will apply here. A lot of laws are there, correct? Let me see if you can answer this perfectly. Please be very much attentive when you're answering it. I'm just reading it for you in case you are missing it. It is 3 raised to the power minus 3, not plus 3. It is 6 square. It is root of 98. So this is square root of 98. This is 5 square. This is cube root of 1 by 25, not the square root of 1 by 25. Then you have 15 raised to the power minus 4 by 3. It is minus 4 by 3 and not 4 by 3. It is 3 raised to the power 1 by 3. So now you have to start doing it. I'll give you like 3-4 minutes. 4 minutes. Take 4 minutes. I have no rush today, because this is just a revision and the good super question class, correct? If you can do this one correctly, I'll be like more than happy. Trust me for it. Take your time. There is no rush. I'm not going anywhere. You are not going anywhere for like these 20 minutes. After that, of course. I'm just taking away my face. I don't want my face to be seen like that. I'll bring it when I will be solving it with you. So I'm still thinking that you people are solving it, and you must be like crazy, like going with this kind of values popping, so many fractions, negative powers, positive powers, different kind of numbers. But mostly there are only three numbers, remember. There is a 2, there is a 3, there is a 5. So the idea here is if you can break this into 2, 3 and 5, okay? All 2, 3, 5, you just try to break everything in 2, 3, 5 and then you collect. I think there will be one 7 also. But that 7 will not make you troublesome. Pushpa came up with some value 28 root 2. I have to come back from this invisible state. Okay. So finally someone has come up with something. Okay. So the first answer that I've got is from Pushpa and she tells me that, sir, it is 28 root 2. Okay. Let me see if others can also pop up. I will give you one more minute to solve. And I have no rush. If you want one more minute and if you say, sir, I'm solving, can you give me one more? I'll give you one more minute. So the trendy games Joan, can you please all change your name? Like come join with some proper name. Why this so weird name? Root of 28. That's different from what Pushpa said to me. Okay. Okay, Lava, I'll give you 2 minutes. Your name is Janita. I have to remember it now. Janita. Can you please change your name in that? It's better, no? Just go and change your name in that. I hope you all know how to change your name. So it's a very simple process. Deepika comes with the same answer. She says 28 root 2. So it has 2 pointers up. Oh, you also are saying the same thing? Okay. I have to give 2 more minutes. Tejas is giving the same 28 root 2. Okay. If you all people are reaching to this. And I hope you are not doing a Google search. Yeah, I hope you really are not doing that. Okay, let me see if anything else pops up. I'm still waiting for Lava to tell me the answer. Tejas has given 28 root 2 only. Okay, Charan, you can solve. Fine. Okay, 28 root 2, Yashashvi, Shivani. Okay, those who are doing, can you please continue doing it? I'm just writing it so that I'm breaking it. The first step will be the same, so it will save some time. Most of it is giving me the same. Okay, fine. Let me just do it now. So this is 3 to the power minus 3. I can break 6 as 2 into 3. So this will be 2 into 3 square. I can break 98 as 49 times 2. Now this is where the magic happens. So if I do 49 times 2, basically this is 7 times root of 2. So this will be 7 times root of 2. And this 2 I can write as power half later on, not now. I may do it. I'm just doing a cheating because most of you have given me root 2. So I'm keeping this as it is. Okay, this will be 5 square. This will be 1 by 25 cube root. So this will be 1 by 5 square basically. And this whole is raised to the power 1 by 3. You people are smart, I hope so now. You know that this is cube root, so this will be 1 by 3 power. Then this 15 can be broken down into 3 into 5. And this will be written as minus 4 by 3. And then this 3 raised to the power 1 by 3. Crazy numbers. Okay. Now, notice what is happening. I'm just still not able to distribute each. So what I get is 2 to the power 2 here. I get 3 to the power 2. I'm using a into b power m. Is a to the power m, b to the power m. I'm keeping this root 2 still as it is. I wish I would have done it as 2 to the power half. You people can if you want, but I'm just keeping it. So this will be 5 square. This will be 1 by 5 square power 1 by 3. So basically I can write it as 1 upon 5 to the power 2 by 3. So this is 1 upon 5 to the power 2 by 3. Because this power will go into division only. Then it is 3 to the power minus 4 by 3. And this is 5 to the power minus 4 by 3. And this is 3 to the power 1 by 3. I have arrived at one point at which that everything is intact. You all get this far, I hope so. Now I am changing the color so that it doesn't mix up with the previous step. It's messy now. So what I will write now at this stage is carefully watch all the 3's can be written in 1 3 now. Okay. So now all the 3's I'm packing together. So this will be 3 to the power minus 3. This is plus 2 because it is in the numerator. This is minus 4 by 3. But I taught you one thing, that when it goes from denominator to numerator, there is a change in sign. So this was minus, it will become plus 4 by 3. This is plus 1 by 3, going up will change its sign to minus 1 by 3. 3 is sorted. Now I can do the 2 square also. So this is 2 to the power 2, this is 2 to the power half. To be honest, I should have broken it also 1 by 2 and should have done it. So I am going to do the same thing, beta. I am not going to be a cheater. So I am going to remove this and I am bringing this power half, so that it is fairly true that this is not I already got the answer from. Okay. Now let me bring my red color pen. Okay. Okay, so at this stage you have got 3 cleared, you have got 2 clear. You are not touching 7 at all because that's like alone. Now for 5 you need to understand I will eat one step. So 5 power 2. This is power 2 by 3, but it is in the denominator of this. So if it goes up here, it will become minus 2 by 3. So this will be minus 2 by 3. It's not going up and up, it's going 1 up only. So it's 1 up, so that's why it will be minus 2 by 3. This is minus 4 by 3 at the same level. At the same level, you just keep on adding it the same sign. You don't flip the signs. If it goes numerator to denominator or denominator to numerator, then you have to do this flipping sign. Okay, nothing else is left. I am sorted here. So I need to change and I have to bring one last step. Okay. So let me bring this last step. Now this is, you can add, okay, minus 3 plus 2 is 1, minus 1 actually. This is 4 minus 1, 3 by 3. 3 by 3 is what? 1. So this is 1, this is 2, 3 minus 3. So this is becoming power 0. Superb. Now you have got 2 plus half, which is 5 by 2. So 2 to the power 5 by 2. Then you have got 1, 7. And then you have got this 5. Now you solve it. This is 2, this is 4. Remember, they both are minus sign. Remember, they both are of minus sign. So the value will add. So this will be minus 6 by 3. What it will be, beta? This will be minus 6 by 3, which is nothing but minus 2. So this is 2, this is minus 2. So this will be also become 0. Crazy numbers, all becoming 0 except for 1. So now you see why they didn't do this root 2 wala. Now this is 2 to the power 5 by 2, not required actually. What you can get is 1 because any number raised to the power 0 is 1. So you get 2 to the power 2 actually left. You can write 2 to the power half and you can write 7. My face should be there. I'm blocking my face for 1 minute. So this is 2 to the power 2, which is 4 times 7. So this is 28. This was actually root 2. I just told you that I did it because I cheated by seeing the options. So 28 root 2 is what the answer is and what the people gave me. And that's why you people are superb. If you are doing it on your own and you have got this answer on your own, I'm just telling you, you people are superb. I love teaching this kind of class. Okay, so let's do now another problem. I hope you all enjoyed this problem, by the way, and I hope you understand that none of the problem is difficult if you know the basic concept and if you go slow and don't make any silly mistake, which is why you should go slow. Okay, let's solve the next one. Find the value of this. It's a very simple question, but I want to see if you all will be able to solve this or not. Let's see. So it is 2 to the power n plus 2 to the power n minus 1 plus 2 to the power n plus 1, 2 to the power n. Oh, so many 2 to the power n. Let's see if you can do it or not. I'll give you, like, for this question, I think 2 to 3 minutes are enough. So take your time for 2 to 3 minutes. So I hope now your exponent is very good. And if you are able to solve these problems, actually this will help you to solve very bigger problems in your next class. In most of the subjects, even in physics, you will find these problem situation, power 1. And people make a lot of mistakes there, I'm telling you. They can't solve 10 to the power 9 multiplied by 10 to the power minus 17 divided by 10 to the power 26. And they make mistakes. I think you people will not do this because you people have done this kind of problem. What I have taught you is, that's why it's beyond books, okay? Because what I have taught you is applicable for each kind of subject, okay? You people are giving me some answer as 1, some people is giving minus 1. I'm going and I want to see which one is correct. So this is 2 raised to the power n. This is also 2 raised to the power n minus 1. But we know one thing. It can be written as 2 raised to the power n times 2 raised to the power minus 1. What do you say? Isn't it true? Huh? I told you that if it is written like bases are same, the powers add. So the n minus 1 will be added because there is a plus, and plus times minus is minus, so it is okay. So this will be 2 to the power n times 2 to the power 1. Why? Because when the bases are same, the powers add. That's why n plus 1 would have come. So I'm breaking it in the reverse sense. You generally have the idea of breaking in the forward sense. I'm breaking in the reverse sense now. So this will give me 2 to the power n. Now focus that 2 to the power n is common. This is how you have to look it for. Look as if this is one value and x. Look, this is an x. And try to take this x common. Okay. So now, let me bring my blue color pen. Okay. So now I have 2 to the power n common. It will give me a 1 here. People do one more mistake. They think there is a 0 left here. No. If you put a 0, then when it multiplies, it will vanish. But this is not vanishing. This is still 2 to the power n. So what you get is this. This is gone because this is outside. This is in the outside world. So you get 2 to the power minus 1. What you are left with is again 2 to the power n common. And if you are quick, you can say that this is just 2. And this is 1. Because it's gone off. So nothing is left. 1 is left. So now this will cancel out. This will give me 1 plus 2 to the power minus 1. Now 1 plus 2 to the power minus 1 is half. And this is 1. This will give me 1 plus half only, which is nothing but 3 by 2. And you people messed up. Those who were saying 1, Shruti, you missed it. Charan, you missed it. Minus, not minus, it's plus beta. 2 to the power minus 1. No, Yashashvi, it is not. So this is 1 plus half, so it becomes 3 by 2. I hope you all have understood now. Great, Janita. Now I remember the name. Okay, I hope I'm pronouncing it right, by the way. Fine, let's go to the next one. Hey, I'm sorry. This is not 2, okay? This is Z. Looks like. I think I typed 2. This is Z, okay? This is all Z, okay? Oh, wait. This is mistyped. Let me see. Oh, man, this is mistyped. I'm leaving this question, okay? This question is mistyped. This question is mistyped somewhere. It is not following any symmetry. Okay, all of you solve this one, the next one. There are so many problems. I won't be like, there's no dearth of it. Okay, you all do it. When will the class end? Whenever you want, you can end the class. In general, the class is 6 to 7 p.m. And if I feel so, I extend the class by 5 to 10 minutes. And that's the end. And I give the rest of the problem as homework. And then ask them to put the answer in the comment box. Okay. Let's do it. You have to prove this one. So in general, you will not do anything special. So let's begin. I'm solving it, okay? So let's start with first step. The first step is pretty simple. All of you, please focus, okay? This is power division. So powers, when divided, they will subtract. So basically, this will be minus AB. Okay. Now, this is what we will do in general. And then we will put the power as A plus B. And then we will multiply it. What I would suggest you to do is not to do this one. Because it will lead to a trinomial multiplying with a binomial. Now, a trinomial with a binomial seems easy, but people do make mistakes. To save you from that kind of situation, let us bring that power directly right away as of now. So, what we get is a square plus b square multiplying with a plus b upon x to the power ab multiplying with a plus b. And wait now, I want to teach you something. I don't want you to solve like this one. I want you to go a little bit beyond this. How you can solve this in Olympiads quicker. Okay, normal maths you can do and I know it. You can do. That's not something big. So what we do here, we rather not solve every other term. Why so? Who told me this? The thing is, you look for cyclicity. Okay, or the cyclic behavior of the terms. Now what is cyclic behavior of the terms? In general, whenever you see that when A is C is replaced by B and B is replaced by C, and this is creating a new expression and it should be followed for every term. So now for A, this becomes B, this B becomes C, this A becomes B, this B becomes C. So every time A is interchanged to B, B is interchanged to C, and C is interchanged to A. And this is how you're getting the other terms. Correct? Yes, Shruti. So not repetitive, we call it cyclic. Repetitive is also okay, but yeah, fine, whatever. So in that situation, what you will end up, if you can simplify this term, you can just then quickly change all A to B, all B to C, and you will get the second term simplified. Why to waste your time and simplify each term separately? That's just bad way of doing this problem. So now what we will do, we will multiply this. We will get A cube plus A square B plus AB square plus B cube. I didn't not do anything special. I just multiplied a binomial with a binomial. I hope you know this, taught in class 8th. This will be x to the power, now multiplying this, A square B plus AB square. Now you see what will happen if I simplify this. I will get A cube plus A square B plus AB square plus B cube minus A square B minus AB square. At this stage, you must have seen something happening, and that is that these terms are getting cancelled out. So what I'm left with is just this term x raised to the power A cube plus B cube, and my life is sorted, and so as yours. Why so? Because now I know this cyclicity is true, it holds. So the next term is just x raised to the power B cube plus C cube. The next term is nothing but C cube plus A cube. I need to change every B to C, every C to A. This is how the next term must have been formed. Now you all have got 1x, so bases are equal. So now you have A cube plus B cube plus B cube plus C cube plus C cube plus A cube. And they all are doubled, so 2 times I can write x raised to the power 2a cube, 2b cube plus 2c cube. And if you are smart, you see this is nothing but 2 common. You get it? How quickly I could have solved it? If it would have been given in my competitive exam and they would have asked, hey, what is this expression equal to? And you must have wasted your time by solving this and this again and again. And you would have wasted like 3 times the time. You get the point? I hope you now understand how fewer skills can change how much time you consume on a question. Let's move to the next one. Okay. Simplify this one. This is pretty simple. Again, this would have been asked in an objective in a very simple way. They could have written x raised to the power a, x raised to the power 1 by a, x or 1, like that. This will be the 4 questions. I could have done that, but I don't want you to do this way. I want you to see it properly, completely, and try to apply your brain. And then I will teach you the different ways, okay? And that's a different approach of teaching. I am solving through this one. Now all of you try to find the answer, like prove it. Try to think and can you prove it that it is x? Okay, let me see if you can prove it to x. You know the answer, apply your brain, get it done. You got it by cancellation process, superb. So this is very simple. This is a minus a inverse, so it is a minus 1 by a, and it is also raised to the power 1 by a minus 1, so I can simply say the powers are getting multiplied. I will keep this one just for my non-messy process. So now you see this is a square minus 1 divided by a times 1 by a minus 1. It will also be multiplied, so 1 a by a plus 1. Now if you people are smart, this is x raised to the power same thing. Okay, now you people see one thing, a is gone. Okay, now a square minus 1 is nothing but a plus b, a minus b. You get it? This is a plus b, a minus b. So this is a plus 1, a minus 1. This is what a square minus 1 is. So basically it is also gone away, because these will also give me a square minus 1, and hence it will just take it away. Now the 1 will be left and this will be x. What happens when they, you know what they do? They just play smart. They give you the option as 1. They do it because they think that most of the kids has this kind of situation where they think that if I cancel everything, it becomes 0. And then it becomes 1 for them. And therefore they take the answer as 1, which you people are not doing it. Because you people know when I'm cancelling it, it's in division and multiplication. And then it should be 1. It's not in addition or subtraction. If I would have done 2 minus 2, it would have given me 0. But I'm doing 2 by 2, so it will give me 1. You get it now? Pure maths, nothing else. Okay. Okay, this is the question again on quadrilateral. I think the exponents were crazy good. This we can do if you are asked to prove that the diagonals of a quadrilateral are equal and bisect each other. One of the question actually went in the typing mistake, I guess so. So show that if the diagonals of a quadrilateral are equal and bisect each other at right angles. So in any quadrilateral, if the diagonals are equal, let us say the diagonals are equal and they bisect each other at right angles. Are you kidding me? We already proved it, isn't it? So can you all prove that ABCD is a square? This is given that the diagonals are equal, that is AC is equal to BD. Also they are bisecting each other, that is OA is equal to OC, OB is equal to OD. Every half is equal. And then in the end they also give you one more thing, they are at 90 degree. I told you that this is the property of a square, remember, and I used it directly. This is the reason I kept this in the last question, so that I can prove it that yes, it is true. Okay, because I used it in the first question, I needed to prove it also. So now you see this angle is 90, you know that this triangle and this triangle are congruent. Hey, such an easy question. So now you see this question, okay, got it, Yashasvi. So now you see these two triangles are congruent. Why? Because this side is common, these sides are equal, and this angle is 90 degree. That's given. So the triangle AOD is actually congruent to the triangle COD. And if it happens, then you know one thing, one very easy thing, that this side will become equal to this side. Is it correct? First of all, understand this part. This side will become equal to this side. So let us say this side is, say, length is small p, this will also be small p. Now I can also right now prove that this triangle and this triangle will be congruent. Similarly, why? Because again these two are sides equal, this is a common side, this is the 90 degree angle. So again SAS, yes, you people know SAS. So these two triangles are congruent, and hence we get this thing that these two sides also become equal. So I have got all sides equal. That's one case. But the trouble is I have not got all 90 degree angles. So I need to get this part, correct? So to do that, I need to look into the bigger triangle now. You get my point? I need to look into the bigger triangle now. You know that all the sides are equal. First of all, you know that this is a parallelogram. Because I can say that is why the true answer came in the last true and false, when I told you that it should be true. Yes, either rhombus or square, but it is a parallelogram because the opposite sides are equal. So it's a parallelogram, correct? It's a parallelogram. Okay, you know that these two triangles are congruent. So if this angle is x, this angle is x, correct? But since the opposite sides are equal, in any quadrilateral, if opposite sides are equal, since I can say that AB is equal to CD and AD is equal to BC, because all sides are equal, opposite sides are equal, so I can say that this is the parallelogram. I have reached to this stage. Now since I have reached to this stage, I can now say that this line is parallel to this line. So if this angle is x, this angle is x. Yes, correct. Now you know that this angle is x. So if this angle is y, this angle is y, like that, everything is becoming like this. So you know that the sum of the angles will be what? 90 degrees each. Same way. So x plus y is 90, you know that x plus y is 90. Keep that point intact. Can you prove to me that triangle DAB is congruent to the triangle CAB? Just tell me that. Can you prove? Because this is x, so this should be x. I have written everything now. Can you prove that triangle DAB is congruent to triangle CAB? Yes, you all can prove. The triangle DAB is triangle CAB congruent? Yes or no? Yes. Why? Because see, DA is equal to CB, DA is equal to CB or CA, whatever you call. Sorry, CBA. It should be CBA, beta. Wait. CBA. I have written DAB, so I should write CBA. Okay. Now you see, DA is equal to CB. Yes. AB is equal to BA. common, yes, and the common and the angles, this side is also equal. DB is equal to AC. Why? Array, because it is given, no, AC is equal to BD. No, Lava, it's not SAS now. You people are doing wrong. This cannot be SAS now. This is SSS. This is the place where you people have to understand. You cannot say SAS. Why? Because DAB, if this is DAB and if this is CBA, then I'm getting this side equal, I'm getting this side common, and diagonals are equal. Given. Yes. So now the two triangles are congruent. This will give me that angle DAB is equal to angle CBA. Okay. DAB is equal to CBA. DAB is CBA. So 2x is equal to 2y. This means x is equal to y. But x plus y is 90. I already told you that x plus y is 90. You can say it in different ways. If this is x, this is y, this is 90, then the triangle sum should be 180. So x plus y is 90. But x plus y is 90 and x is y. So basically x plus x is 90 or x is 45. So if x is 45, sorry for my bad handwriting, then y is also 45. But this tells me this is 45, 45. So completely 90, 90, 90, 90. So all angles are 90. All sides are equal. What is that? You get it? All sides are 90. Sorry, all sides are equal. All angles are 90. What is that? It's a square. Done. Do you all get it? Do you all understand why? How did I use that theorem last one? This was a lengthy proof, by the way, and I wanted you to understand this proof. You cannot use SAS. If you do that, you are making a blunder. You have to use SSS. I just kept XXX so that I make you understand how this all angle will become 90 degree. Otherwise, you couldn't have understood this. This packs the loop, and I think you people now can solve any question from any book. It doesn't matter. You solved R.D. Sharma toughest problems. There is no book at grade 10 till 10th level difficult than R.D. Sharma. And you solved difficult of those problems. The time is over. The class is over. We have packed 3 chapters and we have done it perfectly now. Any error, if I have made, I can go and recorrect it. I'm just telling you one error that I made. This should be true. Okay, I told you that this should be true because it's a parallelogram. It is a child, so you say it's a parallelogram. I think it should be the answer in the R.D. Sharma also. Check for the other questions also and let me know. Fine. This was actually misprinted. I would have wanted you to solve this, but fine, let it go. I think for all intended purposes, if I can solve this one, this should be x minus y. So this will be x square minus y square. This will be y square minus z square. So this will be y plus z actually. And this will be z plus x. Correct. Now the question is correct. You all can solve it. This is z square minus x square. So actually this is a to the power 0. Answer is 1. That was the only misprint. That was z. Everything else is fine. Okay. Goodbye. This was the most awesome class I ever had on YouTube Live. Thanks a lot. Goodbye. Good night. We'll see you in the next session.